Let's start with operators in C++. So, what exactly is an operator? Operator is basically a symbol which tells the compiler that the user is trying to perform some kind of mathematical calculation or logical calculation. In C++, we have a variety of operators, and the most common way of segregating them is on the basis of the work they do, and also they can be separated on the basis of the number of operands they interact with. So what are operands? Suppose consider this statement C is equal to A plus B. So in this statement, the equal to sign and the plus sign are the operators, and they are performing operation on variables which are C, A, and B. So we can define operator to be something which performs operations on operands. And operands are basically just variables and values. So let's take a look at the different types of operators we have in C++ one by one. So the first is arithmetic operators, and the most simplest of all, which just allows us to do mathematical calculation. And let's just look at some code for this. Alright, so we've considered two variables A and B, and we've given the value of A as 5 and B as 4. And we are going to perform the arithmetic uh, calculations using arithmetic operators on all of these variables. So first I've used the plus operator which does the addition, then I've used the minus sign which does the subtraction, then I've done the multiplication, and then we have division, and then we have modulus. So a plus b gives us 9, a minus b gives us 1, a into b gives us 20, a divided by b gives us the quotient. So suppose if you divide two numbers, it will return the quotient. Like if I divide 4 by 2, the quotient will be 2. So, and in our case, we divided 5 by 4. So, we're getting the quotient as 1. And then is the modulus operator, which returns the remainder. So, if we divide 4 by 2, we get the remainder as 0. And in our case, we are dividing 5 by 4, and we're getting the remainder as 1. So there is one thing to note about the division operator, which is suppose if you declare the numerator or the denominator, like any of those to be a floating point number, like suppose if I do 7.0 divided by 2, I'm going and I'll also do C out. Oops. Okay, so I'll also do C out 7 divided by 2. And you'll see that in both the cases, let's just see what the answer will be for both of these cases. Yes, so the first answer is a floating point number, and the second answer is an integer. So we can see that if any of the numerator or denominator is a floating point number, the answer will also be a floating point number in case of division operator. Okay, so let's see what is the next operator which we have. It's the increment and decrement operator. It basically increases the value of a variable by 1. So we have plus plus op plus plus, which is the increment operator, and it increases the value of variable by 1. And then we have the decrement operator, and it is denoted by two minus signs, and it decreases the value of numerator by 1. And there is certain things to note about both of these operators, which we will just see in the code. Okay, so we've declared two variables at the top, which is a is equal to 5 and b is equal to 4. And now what we're gonna do is, so let's look at these lines of codes. So what I'm doing in the first line is I'm incrementing the value of variable a by 1, but I'm using the plus plus operator as a postfix, and in the third line I'm using it as a prefix. So let's see what will be the answer in both of these cases. Let me just explain it beforehand. When you use the increment operator as a postfix, first the original value is returned and then the incremented value is returned. So and uh, and in the case of prefix, the incremented value is returned directly. Okay, so we can see that the value of A was initially 5, and we did the post increment on A. And since it returns the original value first, we get the answer as 5. And after returning the value, it will increase the value of variable A by 1. And now the variable A holds the value 6. And in the next line, we're printing the value of variable A, which is 6. And we can see in the case of pre increment operator used as a prefix, the changed values returned. B was initially 4, and now we're getting the value as 5. So this was about increment operator. And next, what we have is assignment operator. So assignment operator basically assigns the value to the variables. Like in the previous coding example, we initialize the value of variable A as 5, and we use the assignment operator. And we can also, so like if you want to assign the value of A plus B to A, we can just write it as plus sign and equal to. So it's kind of a short form to write these big expressions. And next, we have relational operators, which basically checks the relationship between two operands. And if the relationship is true, we get the value as 1. And if it's false, we get the value as 0. Let's look at the code for this. All right. So we are again taking the two variables A and B. And in the first line, we are checking if A is greater than B. In the next line, we're checking if whether A is less than B. In the third, we're checking if they both are equal to each other or not. And in the fourth and fifth line, we're checking if A is greater than equal to B and A, or if A is less than equal to B. And let's see what will be the answer in all of these cases. So in the first case, since A is greater than B, we're getting the value as 1. And in the second case, since A is greater than B, but we're checking it for whether if A is less than B or not, we're getting the value of 0 because this statement is false. In the third case, we are seeing if A is equal to B or not, which is false, so we're getting the value as 0. And similarly, you can see for last two cases. So this is how the relational operator works. And after relational operators, we've got logical operators, which basically compares two expressions. So relational operator was comparing operands, and now we're going to compare two expressions. These are like logic gates. If you have used it in your 12th standard, like a lot of people have studied electronics. So logic gates like AND gate, OR gate, XOR gate, NOR gate. These were the logic gates, but in CPP we have and OR and NOT. So let's see how they work. Alright, so we are just gonna check the answer for these two expressions. We'll use the OR. Okay, so the first expression is A is greater than B, and the second expression is A is less than C. If the value for both of these expressions is true, like if both of these expressions are satisfied, then only the value of this particular, operation will come out to be 1 because it's the AND operator which we are using. And the second is OR operator. If any of the operation expression holds true, the value will be true. Let's run this and see. So A is definitely greater than B, but A is smaller than. Okay, let's just check it for if also A is greater than C for the first case. So in the first case, we're checking if A is greater than B and also if A is greater than C. So we can see that A is greater than B, but it's not greater than C. But for AND operator to return the value true, both of these expressions have to be true, which is false in this case. So we're getting 0. And in the second case, both of the expressions are true and we're getting the value as 1. But even if any one of these expressions was true, we would have got the value as 1. So this was logical operator. And now we have bitwise operators, and they basically so just return us. So they take the value of two operands and AND operator will return true if both of the operands are true. They work in bits. So basically, bitwise operator is something like it's gonna work with bits. So suppose we have P and Q, and both P and Q are 1, then only the AND operator will return 1. And if any of those bits are 0, it will return the value 0. And the OR operator is something like if any of the bits is 1, like one of the variable can hold the bit 1 and the other is holding 0, and still will get the value as 1. And so they work, so bitwise operator works with bits, and we don't really come across bitwise operators a lot, but they are helpful and handy in a lot of cases. Now, precedence of operators is kind of important, because suppose we have an expression and we've got a lot of operators in that, and we don't know which operation we have to perform first. We've come across a similar kind of situation in while doing uh, while solving questions in mathematics, where we applied Bodmar's rule. Similarly, we have a table for precedence of operator. So the operators with